Hello, uh, my name is Alexey Nikolsky, and welcome on the classes of object-oriented programming. Today we're gonna be a very basic lecture. Let me just check that I'm actually doing some recording. Yeah, I'm doing some recording. Awesome. So, uh, hello again. Uh, Today we'll talk about the classes that will be ahead. Actually, the good news is that the actual classes of object-oriented programming will be not a year, not a half of a year, but a full year, which is very good. Uh, and as you have already mentioned, as you have already noticed, sorry, those classes will be in English. The second part will be at Spring, which will be in Russian. But anyway, uh, this part will be in English, and the structure will be uh, like this. So the first part, this half of the year until the new year, um, vacation will be mostly theoretical, and the second part will be mostly practical. Anyway, in both cases, we'll have labs, and all labs will be um, including some coding, of course, and that's that's a good idea actually. And because practice is very important. So today you see I'm doing the classes online. So not online, but not in university, but in recording. I'm trying this due to the reason you already know, but also I think that the good thing in these type of classes, these type of lectures, is that first of all you'll got actual recorded lectures and you will be able to stop something, repeat, and look at them again, and so on. So it's, I think, more useful for you. The second option is that I can use an internet. I can use the screen of my laptop, which is also good. So I will be able to show you some illustration, and I hope it will be look much better than my own drawing on whiteboard, classical whiteboard. So today I'm trying this application, which is online for brainstorming. For it's a typical mind map that we'll look at. Anyway, maybe we'll change it. So far, so good. So let's look at what we got. Object-oriented programming classes, including a bunch of stuff. First, um, we will got lectures. Lectures, actually, which we have already started. And on lectures, I will give you some information about object-oriented programming itself, technology of programming, modern stuff, like not only actually only object-oriented programming, because I think that um, this approach of programming is not the only one, of course, and it's better to look at object-oriented stuff in terms of comparing it with alternatives that, of course, we have, like declarational programming, like uh, functional programming, and so on. We'll talk about it later. Anyway, object-oriented programming is, of course, one of the most popular one, and you will use it, I think, in the most cases. But it's not the only option. We got another one, so we'll talk about it and discuss it in lectures. More than that, you will got labs. Labs will be you will have to write some applications on different languages. Not we will use C++ as the main language, but actually to understand another approaches and to understand the object-oriented programming approach and compare it with others, you have to new also other languages, programming languages, of course. So we will have labs, which will be not only C++. More than that, we got uh, let's see, extra tasks, and which is not mandatory, so you are not have to do them. Each lecture or most part of lectures, I will give you some extra tasks. Again, it's not mandatory, so you can not to do them at all. But if you really want to be a professional programmer, if you really want to know what is object-oriented programming, what is C, C++ languages, how to use them well, I insist to work and to try to do these extra tasks. The bonus is that they are actually hard. So most of the first one is easy, but most of other extra tasks are hard ones, and they are including not only material that will be discussed in lectures. So labs are based on material in lectures, but extra tasks not. They are separate ones. They are really extra ones, and some of them are really hard. And for example, one of the tasks I'm doing these classes like couple years, I don't know, maybe 5 years, and one of the tasks is done by one to three persons only because it's really hard. But those persons are doing good now, so that's why I think that it's better if you really want to learn how to program, to how to do a programming. It's better to do an extra task. The bonus is that on lectures, and today I will give you an extra task, the first one. Uh, I will give you a task, and you will have a week or two to make it. If you do, if you make a decision, oh sorry, make a solution for this task, you will send it to me to my email. So please send me the email on send me the solutions of this extra task on email. This one. So and say that this is a solution for task number one, and this is it. If I have received the correct solution, I will give you pluses. So we got pluses. Oh, that's sorry. Oh, maybe it's pluses. So it's something like achievements. So it's like pluses, and you will be able to get those pluses on extra task solution, on practice lectures. Oh, sorry, on the practice classes, or by doing labs, by extra tasks, and extra additional tasks will be also in each lab, so we'll be able to get some pluses too. Um, what you got on pluses? Pluses, it's your own personal stuff. I will not public the actual number of pluses per each of you. I'll just collect them in my own table, and uh, so it's actually a personal thing. So at the end of this year and end of this semester, you will have to pass an exam, and the bonus is that at the exact day of exam, the groups that will have to pass an exam in this year, and this day actual day. So if you have like two groups that are passing exam in this day at the same time, I will look at the list of those persons who able to pass an exam. So we will got an exam. So we got an exam, and this exam uh, will be also in English, and it will be like a test one. But uh, at the day of exam, I will look at the list of persons who can pass an exam. Is this is to allow to pass an exam, you have to pass labs. So if you make all labs required for this semester, you will be able to pass an exam. And at the day of exam, I'll look at the list of the persons who are able to pass an exam and look at the values of number or the number of pluses they have. And the top three persons who got the most amount of pluses will pass an exam on 5 or like A in English notation. So it means that you got automatically pass an exam. I will just take and you will not have to pass an exam anymore because you got some pluses over there. So five top three persons who got automatic 5. Next uh, three persons who got automatic 4 or B for exam, and or only one question but complex question to solve. If I got the solution of this question, you will get 5. If not, still you will get B or 4 for your exam. So anyway, pluses is an ability to pass exam automatically. Again, I will take only top 3 persons for uh, totally it will be top 6 persons who will got some bonuses on pluses. And it is only so it looks like some competition stuff between you. So if you got more pluses, you will be able to pass an exam. And more pluses you got, the more probability that you will pass an exam automatically. And the thing is that it doesn't matter which actual value of number of pluses, because sometimes looking at the years I got, and there was a person who do all extra stuff on labs, do all extra tasks, and he got something around 30 persons, 30 pluses. So it was a top guy who got, of course, an exam. And sometimes I got only 3, 5 persons who are able to pass an exam, and they have like something like 3 pluses or something like that, and they will got automatically pass an exam in this case. So again, it doesn't matter the actual number of pluses. There is no edge more on what you got an exam. Only competition. So top 3 will got 5. Next top 3 will got 4. This is your ability. Okay. So again, you will got an extra tasks, send email to me, and got your pluses. Don't worry, I will only only answer on emails if you got correct solution. That's why I'm using email, so they will not miss. So don't worry if I am not answering you. I will show you the solution of an extra task on the next lecture. So today I'll give you an extra task, and the solution of this extra task you will hear on the next lecture, and you will know if you send me this correct solution, then you will be sure that you got a plus. Some of tasks are more complex, so they will get 2, 3, 4, 5 pluses on to solve this to the solution of this extra task. And first one is easy, and you will got only 1 plus if you give me the solution, because it's really easy. So let's go to the exact extra task. So extra task looks like this. You got this code, and this an application. This is a code for application, Of course, you need something like include printf to declare it, but anyway, this is a workable code. And if you are good enough, you see that this application doesn't print anything because it's a zero and this comparing and I minus minus, so it's not something with printf. So it's not printing 20 stars. The key thing is that the task is that you got exact code for it here, with all spaces, with all stars, punctuation, letters, and so on. Look at this code, and you have to replace only one symbol in this program, maybe this, like U, or like 5, so something like this. So you have to change only one symbol over here in all this string to make this code able to print 20 stars, exact 20 stars. So replace one symbol to make this program print 20 stars. The thing is that you have to give 3 different ways to make it. So I need to get 3 different solutions of this one symbol replacement stuff to make this application print 20 stars. Secondly, I need you to replace one symbol to make this application print 21 star. And there is only one solution, so please give it to me, only one. One solution. One way to do it. So totally, I am waiting for 4 solutions for this problem. Okay, so again, you have a code like this. You have to replace one symbol to make this code after compilation print 20 stars. I need you to give me 3 different ways to do it, so 3 different replacements. Secondly, 4th replacement of one symbol to make this application print 21 stars. So totally 4 solutions. So if you send me in email these descriptions of these solutions, so please send me an email like, in this code replace this symbol on that symbol, and you will got something, the solution. Solution looks like this: replace one symbol like 0 on 5, and you will got the solution, something like that. You will got 1 plus for this. If you want to get 2 more pluses, you need to give me not only these 4 solutions, but a script or application with the code, of course, that automatically determine all one symbol replacements in this code that will make after this replacement a correct code that will print finite number of stars, or let's say less than 100 stars. Let's say like this. So I need you to create a script on the application, on the code you like, on the language you like, that will automatically determine all one symbol replacements in this code that will make a correct code. After that, we'll print finite number of stars, or not finite, but less than 100. It's better to, it's more correct way. So, and of course, with this script, you'll also give me all these replacements, not only. So the good check is that your script at least have to give me 4 these solutions, but maybe something more. So this is your first extra task. It's easy one. It's an extra task. Send me solution here, and you will get your pluses to be able to pass an exam automatically at the day of exam. Okay. What else? What else we have? So far, so good. The labs. So I will give you lectures in this way. So it will be recorded, and you'll be able to just download it and uh, listen, look, and so on. You'll get labs. Labs will be done not by me. It's Andrei Yurevich will give you the labs classes for object-oriented programming. Uh, you'll get some classes with him, so I'm not really sure the exact uh, content of labs, so he will give you all information about that. I will do only one group with those labs, and they will be the same as on the Yurevich, so I will give you some list of labs you'll have to do, and for me, you'll just send me some emails about that and so on. So something like that. It will be a separate lecture about that, and that's okay. Anyway, you will get your practical um, classes on labs. So if you pass all labs required, you will be able to pass an exam. That's all. The exam will be in English. The exam will be in writing. So you got some tests, and the test not only like select the correct answer from these 3 ones. No, it will be in writing. So you will have to draw some schemas, so write some code, write some text in English that describe the answers for these tests, and so on. So it will be a good exam. Of course, exam will be only based on lectures that I will give you, and I think that it's better to go on and start our lectures. So, about the structure of the class, I think it's all. So let's look at, can I create some new one, add, fill in a blank example. Oh, so really, I can't add some extra. Let's look. Yes, add that. Okay. So, let's start to think about object-oriented programming. The good thing is that object-oriented programming right now is the main approach to develop and create applications. All modern applications are based on or created with object-oriented programming approach as the main part. It's not the only approach to create and build applications, but it's the major one. I want to start our lectures with traditionally with a very nice book, Grady Butch, Object-Oriented Analysis and Design. So we'll start with the actually a joke. Uh, I'll read it. Let's. La, la, la. So Grady Butch, first of all, Grady Butch is the guy who actually one of the author of object-oriented programming approach itself, and this is a basic book. The book actually is a fantastic one. It has very nice illustrations like this, and we'll look at this and insist you to read this book. It's very nice. Um, it was translated in Russian, so you can find it in Russian. Also, I want to give you the list of books which is good to read, but it will be a little bit later. First of all, I want to start with complexity and this nice joke. So let me read it for you. A physician, a civil engineer, and a computer scientist were arguing about what was the oldest profession in the world. A physician remarked, "Well, in Bible it says that God created Eve from a rib taken out of Adam. This clearly requires surgery, and so I can rightly claim that mine is the oldest profession in the world." The civil engineer interrupted and said, "But even earlier in the book of Genesis, it states that God created the order of the heavens and the earth out of the chaos. This was the first and certainly the most spectacular application of civil engineering. Therefore, fair doctor, you are wrong. Mine is the oldest profession in the world." The computer scientist leaned back in her chair, smiled, and then said confidentially, "Huh, but who do you think created a chaos?" Oh, I really like this story because all the thing is in programming is about complexity. And actually, I think that the main thing that uh, programmers is dealing with complexity. Modern applications are very complicated. They have millions of lines of code. You can imagine, like, let me take like this web browser that actually hosts a plugin that draw a PDF file, and it's another format. It's another application that hosts inside the web browser as a plugin. The web browser also is a platform that works in a more complicated application, or like it works not separately. It works in operating system of Windows. Right now it's Windows 10, and web browser is just an application of this Windows 10. And Windows itself, it's a huge system that includes a lot of binaries. You can just open this like C and Windows and main folder like System32, and you see it's just folders with all wrong stuff and and a huge amount of different binaries. You can see it's like a lot of different binaries, and we can look even on the kernel and TOS kernel XZ, which is working right now. This binary is like 9 megabytes of code. It's like 9 million bytes, and it's a lot of code. It's like something like 30 million lines of source code, which is built in this one. It is created by somebody have created a C code, which is a base source code for the NTOS kernel, and it was passed to a compiler, a set of different compilers that build each source file, then create an object file that then a linker takes it and build a one single binary, and this is on the kernel, which works in kernel space. We also have drivers, so we have different libraries, and like this is a set of driver, which is also not very small ones. It's like 3 megabytes and so on. It's huge ones, and a lot of binaries work right now. And more on that, we have the operating system doesn't uh, frame only by kernel. It has drivers, it has processes, it has um, It has a processes, a lot of process. Let me see, uh, details. This is a list of processes that works right now. Each of these SVC hosting Z has a hosted service inside, which also communicate with other applications on the IPC mechanics, and iterates between it interacts. So all these applications are not working separately; they communicate with each other. Some of them are work with internet connection, some of them with application, so on. So modern applications or modern information systems are really complicated. You can imagine the amount of code, amount of bytes, amount of instructions that actually CPU have to execute to draw these just this story on the screen. It involves the video driver, the parser of PDF format, the base environment of web browser, the millions of different system calls to operating system. It's something like a million system call in a second right now, which allow to work this operating system. Not in a second, it's like hundreds of 100,000 of system calls right now. Million a minute, million a minute, yes, something like that. So anyway, modern systems are complicated. That's why you have to. So it's not like Hello World or just compare two numbers on CPU. It happens a million times a second. So main goal of programming is creating code which allow us to deal with this complexity. So first thing that let me say is let's look at complexity. Complexity. So complexity. So programming is, or let's say information engineering is dealing with complexity. The good thing is, or like looking at your specialization is information security. Complexity creates uh, a complicated stuff, makes people to make mistakes. So mistakes, complexity is cause of mistakes. Mistakes make bugs. Be sure Windows has bugs, and any application has bugs, and your application has bugs, even a very small one. The main statistics is something like each 10 lines of code in C has a bug. So something like that. Windows has 16 million lines of code, and you can imagine amount of bugs it has. Actually, looking at this and like looking at my own experience in information technologies and understanding how operating system works inside, actually it's a magic that it actually works. Like I can move a mouse and look at the screen and see that I can move this stuff on the screen. Like, wow, it works. It's very complicated stuff. How does those engineers make it work? Not sure. Some bugs may produce um, an issues, which is I'm sorry, I forgot this word. Like not issue, issue, not issue, but which is the base stuff. Which what can produce bugs? Bugs can produce um, use some stuff like issue. I really forgot this word, but these issues may be cause of exploit or like. Let me Google. Really, I just forgot it. I'm just a person, so I can't forget some letters, some words. So exploit uh, cause. exploit, exploit, vulnerability, vulnerability. Yes, this is the word I have forgotten. Vulnerability. So, return to our. So it's not an issue; it's vulnerability. So some of bugs may be because of vulnerability, which is an issue in the application that can be that can damage this application or damage the data um, that application uses. Some of vulnerabilities may be caused an exploit. So it means that it's an application or the code or the script, something that use vulnerability to make use of bug and or mistakes in application that may damage the code, the data, anything, or like make uh, problems with information security. So complex systems produce exploits, which is the direct connection with your specialization. That's why you have to be the best uh, in creating dealing with complexity to not to make mistakes, not to make bugs, not to cause an vulnerability. Of course, you make mistakes. The thing is not trying to disable mistakes at all. Of course, you will make a mistakes, but not all mistakes makes bugs. Not all bugs makes vulnerability. Not all vulnerabilities possible to create an exploit. Your goal is to deal with complexity, let some mistakes be, but those mistakes don't mm, be able to cause an execution. So the idea is to does not allow mistakes those that can make vulnerability and exploits that can cause vulnerability and exploits. Um, this is the main thing. Uh, just pause. Sorry. Uh, so again, the goal of programming is dealing with complexity. The thing is that you will have to create complicated applications anyway. So creating a simple application is not interesting. It's not the thing that it's like, oh, it's not interesting, I will not doing. It's just not something that's required in our modern world. Modern applications are complicated. So you have to deal with them and allow to create them. So the good news is that dealing with complexity, you have some tools or like tools. You have tools to deal with complexity. Actually, you have a lot of different tools. So you have, uh, let's say, software tools. So yes, you have things like Visual Studio, like compilers, like different editors that has a nice highlighting of syntax, that have some checks, some testing tools, some profiling, debugging, a lot of stuff. So actually, like let's say debugging, uh, development, uh, source code editors, and so on. So a lot of software tools. It's practice stuff, but you have to know how to use them. Any engineer have to know how to deal with materials, how to deal with something like hammer, something like scissors, and so on. So any engineer have to know how to deal with tools. You also need to know how to work with debuggers, development tools, software that allow you to analyze applications, source code editors, and so on. Basically, we will talk about them in detail in the spring, which is more practical stuff. So right now, you just have to know that you have those tools and you need to know how to use them. Visual Studio, for example, is a huge um, software, which involves a lot of other software like compilers, debuggers, and so on. It has a source code editor. It has different editors for profiling, for schemas, and so on. So you need to know how to use these tools to be, which really may you help to deal with complexity. The thing is that it doesn't only stuff that you have is don't it's not connected only for software. You have, let's say, how I can write it. Let's say you have um, collaboration. Modern application modern applications are too complicated to be created by only one person. So you need to collaborate with your team uh, and to work with them to create something more complicated than you can create by your own. You can take like Windows or like any modern game like I don't know anything that really complicated stuff, and it is a result of collaboration of a lot of people, which created. Some of them are drawing, some of them are creating code, writing scripts, debug stuff, create an engine for a game, rendering stuff, creating hardware, and so on. So the result that you can see right now with a web browser and the picture here, which it is a result of collaboration of a lot of people working on years that finally got this possible to that we can communicate like this. So you need to collaborate with all persons uh, that is possible to involve in creating more complicated stuff. Again, the idea is that if you are the uh, only one developer, you can create some game right now, which is not very complicated. You can create some simple software, but only in collaboration you can create a really complicated and hard and interesting systems. So collaboration is also ability to deal with complexity because you can create more complicated stuff. What next? You can use already done, or like, let's say, reuse, no, use existing mm, resources, let's say. So you can use APIs like operating systems, operating systems, APIs, libraries, uh, GitHub, whatever. So a lot of stuff is already exists. So you can look at documentation, existing code, resources, existing libraries. So let's say you don't need to create a video driver. You can use it inside an operating system. You don't need to, let's say, deal with some USB device or something that allows you to analyze the network traffic. You already have, let's say, a pickup library that allow you to get network traffic and analyze it. So, or maybe you don't need to create some mathematical library or a cryptography algorithm. We have it already. You can look at the GitHub. You can look at the libraries in the operating system. You can use already exist APIs, anything. So you have a lot of different resources that allow you to create more complicated stuff. You don't need to create it from ground zero. So you already have some resources to use, and why not? It's a good idea, and actually modern applications are not creating from the ground zero. Of course, they have already some engines for games, some resource libraries, some already created 3D objects that even designers take them as a base to create whole virtual worlds and anything. So you can use it, why not? And even in creating labs or solving some problems, deal with it, use it. But the thing is that you need to know how to use operating system, what system calls they have, what libraries you really already have in your system, APIs you have already and you can use. So uh, the my thought is that even you have already created, we have already a lot of stuff right now that is ready to use, but you have to know how to deal with it. Let's say, think about like, do you know all list of supported system calls that operating system has? Let's say, let's look at them, like Windows system calls, Windows system calls table. Let's look at them. Wow, this is a list of system calls. You really know all of them? Let's say you create, I think that you know like create file. Yeah, NT create file, yes, I think you know this one. But all rest, like, come on, it's like set IO completion, like, or unload key, or whatever. It's a lot of things. That's why it also actually gives you more complexity, but it's something may be easier. And it gives us next option in complexity and tools. It's actually the mm, approaches, or no, like mm, fundamental tools. Fundamental tools. These ones are exact tools like software, like uh, collaboration, and also software dealing with collaboration, like let's say Git or whatever. So let's talk about more fundamental stuff. Let's say you have to create an application. Application looks very complex. So let's say you want to create some game, something like GTA 5, whatever, like GTA 6 or 7, doesn't really matter. You have to create a complicated application that involves a lot of technologies, that involves like creating the world, virtual world, entities that work there, transport, roads, city, dialogue system, quest system, and so on. So it involves a lot of things. But what you can do with that complexity? Actually, you have some things to deal with. Uh, let's say the first fundamental tool is decomposition. Decomposition, which means that if you have some complicated problem, you can decompose it to smaller parts. And the base idea is that if you have some complicated, huge system, you can decompose it on parts. Each part you can look separately, and this each part will be less complicated than the whole thing working together. Let's say uh, you have a jet or like a rocket. Uh, Rockets are very complicated systems, like a rocket. Let's say I just want to illustrate it. Rocket. Where is pictures? Uh, Rocket photo. Yeah. Oh my. Space. Space. rocket. Oh, yeah. Let's say you have a rocket. Oh, like this. Yeah, you have a Lego rocket. Yeah. Decomposition is the process of decomposing this complicated stuff on parts. You can use a Lego and this the like the same idea with the bricks. You can take this part of the rocket and look at it separately, like this, whatever it's like for fuel, maybe fuel tank, or the main part of the rocket, which is useful stuff, and so on. So like also involves some. Actually, the good idea here is that rocket itself doesn't work separately from the platform. It's based on the special stuff that holds it, and you can look at the any application as a rocket because it works some operating system. This is the operating system stuff around rocket. The persons who prepare this rocket to start, move it in the good position, and allow it to work. So the persons who build this rocket are the software engineers that create an application like this. Anyway, returning back to decomposition, you can like decompose the rocket on the parts. Rocket decomposition. Let's look. Yeah, it's inside of the rocket. It has these one, two, three, four, five. Like it has parts, and software itself also, as a complicated stuff, also have parts. It has libraries. It has APIs. It works in this part works with this kind of APIs. Let's say a web browser. Let's take a web browser. Web browser you can decompose on like a rendering engine that renders this stuff on the screen. It has a tab manager that manages these tab switching. It has a part that work with the mouse, with the keyboard, with the rendering itself. I have already mentioned it. With rendering of video, with passing audio from internet to your audio controller that produces sound, or also you have a subsystem that works with network connections, something that works with advertisement, something that works with checking and all these things. So actually, and works with plugins. So again, we can decompose the complicated application in the parts and look at it separately. We can take the part of web browser that only works with network connection and look at it that gives some abilities to work with others. And don't think about rendering stuff and think only about network connection. So it's about decomposition. Okay, this is a fundamental tool that allows you a complicated system decompose on parts. Each of these parts may be will be less complicated and it's easier to work with than with a whole system in altogether. So next one is composition. It's an opposite action which allow you to compose smaller parts in more complicated stuff, but which looks very solid. So the example with the rocket. Let's take a rocket and decompose it from all details that you can possible to decompose from one to another. So it will be some uh, very small metallic parts, plastic parts, which will be collected to each other. Let's take like another example. Let's look at Lego rockets. Let's say, yeah. If you take this rocket created with the Lego bricks, then if you use only decomposition, it will be Lego details. It will look something like this. So your rocket will be looked like this. So separate parts and not connected to each other. Each of part is very simple, but looking at this chaos still looks very complicated because now you miss the how does all of them have to be connected to each other to build a rocket. So it's a rocket. It's the same rocket, but it's just with the bricks itself. So the same idea. If you take a software and decompose it till the last possible part, something like instruction, for example, uh, or yes, if you take an example, so the smallest part of Lego is a brick, and the smallest part of application will be something like instruction. And if you look at this instruction set, let's say we take NTOS kernel and look at it in hex. So we got all these bytes. Actually, yes, maybe not only instruction, but bytes. Look at this. This is the composed Windows kernel. Is it easy? Is it understandable? Of course not. And actually, I can even here see the frames between some functions. You can see that this is function. It's the beginning of the function. CCC is alignment, and C3 is return. So even here you can see some parts. But look at these hex values. It is complicated. We have decomposed Windows right now on the smaller parts, on hex values, which if we combine multiple hex values, they will make an instructions. Instructions will combine with each other, will make some statements in C code that was created by engineers, and so on. Finally, C statements combine between each other will make uh, some abstraction layers, APIs, functions, and so on. So we need composition to collect smaller parts in some more uh, huge parts, but more understandable. We can compare bytes. We can uh, compose bytes in instructions. We can compose instructions in statements. We can compose statements in functions. We can compose functions in some API layers, functions in libraries or modules, and so on. So we can compose them back. So you need not only decomposition, just decompose stuff in parts, but compose them in some smaller parts. What next? Next thing is metaphor. Metaphor. Metaphor is very important stuff. Metaphor allows you to name something. So this is returning back to Windows kernel. It's a Windows kernel. It has bytes, it has instructions, and actually this stuff works right now. But it's not understandable for human reading. To allow it to understand, we can use metaphor. Just name this stuff as an instruction in 3. We can name this stuff as an instruction as red. And this stuff, after naming, become more understandable. Let's look at, let's say Visual Studio. Maybe it's easier to understand. So idea of metaphor is naming. So we can name functions, we can name variables, we can name instructions, we can name modules, and so on. So assigning some understandable stuff for, let's say, creating a new project. Yeah, just so using metaphor allow us to deal with complexity by naming some stuff with understandable names, with understandable captions, descriptions, comments, and so on. Actually, it is very important stuff, and how you use metaphor basically depends the most part of dealing with complexity. If you opposite example, if you are not using metaphor well, you can got the code like obfuscated one, like obfuscated C sharp code. Let's look an example. Example. Can obfuscate my C sharp code. Blah 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 blah. Yeah, C sharp obfuscator example. Yeah, this is, I think, looks well. And this is obfuscated code. So this is well code, which we see like start string, to string, which gives us some information about basics inside of what was the goal of this function. Like to string is function translates something to string, which returns by string. But the same stuff obfuscated looks like this, and it's a little bit less understandable. This is example of bad use of metaphor, obfuscator, and this is the table that gives what was next, what was uh, comparison, what was replaced on what. Uh, so doesn't got Windows Wizard blank solution. No. Windows Desktop Wizard. Yes, this one. Doesn't matter. It's an empty project. Yes. So maybe I will give you another example. So metaphor again. It's naming. Uh, so the last, not least, is categorization. Categorization, which means that it works in combination with composition. Composition is just raw composition, some elements with each other, just taking bricks and connect them and build some parts of rocket. Let's say you take some of bricks are created this tank, and this is composition. So we take multiple details, combine them, and make a tank that will lately be connected to the whole rocket. But categorization means classification. We classify details in categories, like instructions in categories and functions in categories, whatever. So if we look at example with a Lego, and we look again the start as Lego bricks, like here, we can categorize them, let's say in colors or in form. We have 4 on 3 brick, 1 on 2, 2 on 2, 3 on 2, and so on. So we have different bricks. Not only by, we can categorize them by color, we can categorize them by form, and so on. Categorization deals with complexity by allowing us to look at one category instead of set of details. Category gives us information about the properties of these parts of the application, of the actual stuff, of the rocket, whatever. The good thing is that this is fundamental tools, which means that all of them works not only for software development. Each of them has implementation in object-oriented programming, in other approaches, but they can be used not only here, but in dealing with any complexity, with your personal life, with if you will have to create some, let's say, build a house, so create a jet or whatever. Any complicated problem may be found a solution using these fundamental tools. The last thing that I want to mention here is goal thinking. it's also important stuff. It actually combines all of them. Goal thinking means that you always need to think about the goal of function, the goal of object, the goal of your code, of instruction, of naming, whatever. So let's say using a metaphor has a goal, and which means that you have to name some part of your of your program with some name, and the name needs to be easy to understand the goal of this part of application. If we take a Lego again, uh, so we have named this part of the rocket. Let's say this part of this rocket I have named a tank, and I'm using metaphor to name this part as tank. Tank with the fuel inside is the goal of this name of this detail. This detail has a goal. It keeps fuel inside, let's say like this. Or engine over here, it works and spread the fuel and run and burn it to allow a rocket start. So each detail itself has a goal. Each combination of details also has a goal. Name of this detail describes this goal. Decomposition and let's say work or like execution of each of these tools have to have a goal. And before doing decomposition, metaphor, composition, and categorization, of course, has a goal. Why we need to categorize all details in color, or why we have to categorize them in form. Each of it has a goal. Maybe we don't care about color, building some using the Lego details. We don't care about color. We care only about form that we got. Maybe we built a wall. It doesn't care about color, and sometimes we need a color to create a picture using these details. That's why if we don't need to categorize them in color, we don't have this goal, we don't need to do this categorization. And that's why developing application, the same idea. We don't need to do some decomposition sometime. We don't need to use object-oriented programming sometime. We don't need to name something. We don't need to compose something or to categorize something. So before doing any action, think about the goal of this action. Again, all of these tools combined together allow you to deal with any complexity, not only software engineering. That's why it's very important to understand them well. Of course, next in lectures we'll use all of them, and all of them has implementation in computer languages, in programming languages, in software tools, in collaboration, everywhere. So please remember that those guys are the main part, and all of next stuff is just implementation of them. So next category of tools you have is programming languages. We have programming languages. We have a lot of programming languages. C, C++, C Sharp, JavaScript, Prolog, Python. Uh, we have Go language, Lisp, Haskell, more on that. Like if we open Wikipedia, like programming languages, Wikipedia, what we have. I hope we have a list of them. Blah 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 blah. Where is the list? Like list. Ah, that's the list. Ah, list of programming languages. Yeah, awesome. Wow. log module, and this is all. Each of item here is a programming language, and there was a reason why people create them, because each of this language has advantages and disadvantages. Each of them was created for some goal. Some of them, so the thing is that all of them has advantages, disadvantages, some constraints of use, and so on. Some systems where it is possible to use them, some systems where it is impossible to use. And again, the goal thinking. Don't think about popularity of languages. Popularity of languages doesn't give a lot understanding of really what language can and what it cannot. It doesn't tell you advantages and disadvantages. The idea of populating, or like which language is the most popular is the same question like which tool is more popular, like hammer or a scissor? Which is better? Like, come on. Of course, there is no comparison between hammer and scissors. Somewhere it's easy to use scissors, somewhere it's easy to use hammer. The same idea for computer languages. So somewhere it's easy to use BASIC, somewhere it's easy to use C Sharp, some places it's easy to use C++. So the more tools you know, the more languages you know, the more professional you are. The more um, tools you can use to deal with complex applications you have, to deal with constraints you have in your application. The same idea is everywhere. There is no need to compare like Visual Studio is better than Xcode. Like why? Somewhere you can't use some things like Xcode on Windows. You have to use Windows as a constraint of your problem. Use some tools that are easy to use there. So, of course, it's possible to compare Xcode and Visual Studio. Both of them are development environments, and both of them use some compilers and so on. Even compilers can be compared. They have a speed of generating a code, they have abilities and supported languages and so on. But comparing them, don't think about popularity. Think about usability. What particular problem you have, what uh, constraints you have, and what tools you need to solve them, and and choose tools only thinking about the goal of your application, only about constraints you have. Another option, also important, is that choosing language and choosing tool, you also have to think about what you already know. Like, let's say, like list of languages. I don't know language DCL. I will not use DCL because I just don't know it. Maybe this is the best language to solve my problem, but I just don't know it. Maybe it's better to look at it and think maybe it's easier to learn it and then use it. But sometimes you may have a very small problem, which is better to create by manually by the languages you already know and not spending time on learning this language. So select tools wise. Of course, more tools you know, more professional you are. But if you know a lot of tools, a lot of languages, but each language very weak, knowing it's not good. It's better to know some language like C, C++, or C Sharp. Absolutely exciting. I mean, like, have a lot of experience in that language. And some other languages with some less understanding. But actually, the core idea is to make not really depend on language. If you need some language, just you know that you spend some time and learn this language, and that's all. But you already, of course, you don't need like years of working with this language, but to deal with some particular problem, it's maybe easier to do this way. So The better approach, I think, is to know some set of basic languages that you know very well, and also be understand it that it's if you really need some DCL language, you will learn it. If you don't need, you will use some existing language that you already know. That's all. The same with all other tools. Uh, so I think that for today is more than enough. We will continue to uh, work with complexity. Oh, you see, we have a lot of tools actually working with complexity and software tools, collaboration, and resources. We will talk about this stuff more detailed in the spring. We will next lectures continue to work with fundamental tools and thinking about programming languages. Uh, it will be in the next lecture. On the end of this lecture, I want to give you a list of literature or books that I think is very important to read and to know if you really want to become professional. So first is Grady Butch, uh, Object-Oriented Programming. This book, or it looks like this, is this book also you can find in Russian. Object-Oriented Analysis and Design is a basic a book that you have to read. It's about object-oriented programming itself. Next, uh, Herb Sutter. Our basic language will be C++. So Herb Sutter has a bunch of books like this. Exceptional C++ coding. It looks like this. It's a series of books. The idea is that those books, if you really want to know how C++ works inside, and if you really want to be a professional C++, you have to read all of them. These books are based on problems and solutions that Sutter gives you, uh, and through this way, through the solving some problems, you will learn C++ much better. C++ actually is a very complicated language. It has a huge syntax. It has a lot of functions, a lot of features, and we'll talk about them in detail. But these books are the best for them. Little bit less uh, uh, easy, a little bit more easy books. It's really complicated books, but you have to read them. Myers, Myers, uh, C++. Yeah, it's a C++, C++, Myers. It's like books. Yeah, it's books like this. Uh, Scott Myers. Yes, this bunch of books is from Myers about C++. It looks like Sutter books, but a little bit easier. It's good for start, and then back to Sutter. What's next? Next is I will type it in Russian. Yeah, this book, Alan Cooper. It's best book about interfaces. So you have to read it. It's not very huge one, but it's very nice. What's next? Uh, Brooks. Frederick Brooks, Mythical Month Man. This book is about application programming itself and without code at all. You have to read it. It's not big. It's about programming itself. Very nice book. It's about a little bit about project management and dealing with complexity. What's next? Code Complete. This book. Steve McConnell. Code Complete. The best book about construction of application, how to actually write a code, how to select names for variables, how to create and organize your code itself, how to write comments, and so on. We will talk about it more in detail in the spring, but it's the best one. You have to read it. I think that the basic books it's enough. Actually, it's a very huge book, but it's very nice. If you need to know more about applications, no, sorry, about operating systems, you have to read the book, of course. Uh, this book, Personage and Solomon, Windows Internals, of course, be sure to read it if you want to program in a language. Uh, sorry, in Windows. Then Linux kernel. This one is for the same but for Linux. Next, uh, Yuri Shvahari, Unix internals. This book, all of them actually you can find in Russian. So I'm just because we have classes in English, I'm giving you an English books. You can find them in Russian translation. You can find in university uh, bibliothèque. So university library, sorry, university library. You can also find them. So Unix internals. It's about operating system itself. How does it works? What is uh, scheduler? What is interrupt programming, and so on. So if you want to uh, work with C sharp, the best is yeah, Jeffrey Richter. Two books. Uh, where two books of Jeffrey Richter, Windows via C++, and dot Jeffrey.net via C Sharp. It's about programming in C Sharp. Mm, Jeffrey Richter, also Sealer via C Sharp. The best book for C Sharp. So and .NET itself. We will talk about .NET, of course. I think even in this semester. Yes. For today, I think it's enough. So thank you for listening. Today, it's enough. See you in the next lecture.